Here is the crankshaft position sensor pinout with the colors of the wires.
Our crankshaft position sensor is located right down here behind the crankshaft pulley, and it is a 4-wire sensor.
Here is our crankshaft position sensor circuit, our yellow wire, light blue, white, and black and white wire. For this lab, we're looking at the 2000 Buick Lasabre again. We're back probing currently the crank position sensor and letting it run. We're seeing the signal pop up here on the computer on the picoscope. We can see that as we rev the engine, the signal actually gets tighter and will read faster. Here we are looking at the frequency of the crank position sensor. You can see the frequency right there is 47 hertz at idle. And when he revs it up, you can see the hertz climb. With the sensor on, we're running at about 5 volts. Here we have the crank position sensor plugged in and connected, verifying. We have voltage 6.68 at my multimeter and right around 6.8 volts at the picoscope. Using this test, our next test we will be doing is grounding out the signal circuit with a test light to see how the picoscope and the multimeter react to each other. With key on, engine off, and we can see with our test light we are going to ground out the signal. And you can see how the picoscope responds to being grounded out. In this test, what I will be trying to conduct is seeing if the engine will start with the signal circuit actually shorted through my test light. So it does not want to start because the signal is actually shorted in the test light. With just key on and the engine on, you can see that we are running getting a good signal off the signal wire, with in conjunction to what we are seeing with the 5 volts. So now what I'll be doing is grounding out the signal using my test light, and it dies. Now I will demonstrate what happens when you try to start the car with the crank position sensor shorted out. Go ahead and start it up. And watch it's not starting. Once you test light away, the ground, or the short in this case, it will allow the motor to start. And to shut it off, you can simply touch it and it'll ground it out. Thank you. Here is the camshaft position sensor pinout. In order to make sure we are getting correct voltage and that our back probe is okay, we are looking at the hertz of the sensor right now. So when the sensor revs, you can see the hertz start to climb a little bit. Looking at the picoscope reading of our cam sensor here, you can see our frequency down here is lining up right around 7 hertz, and that lines up with our reading we're getting off the multimeter at the same point. So here, what I'm demonstrating, you can see that these little parts here that I'm circling with my finger, those are noise probably from a injector or, different voltages in the system. You can see here the actual drop of the sensor, and we're averaging right around 9.5 milliseconds in it, so that's showing the 0 time of the sensor. So now what I will be doing is shorting out the cam sensor just like I did for the crank, and we'll see the reaction of the multimeter here and of the picoscope over there. So now what we're going to do, what I said before, was we're going to ground out the signal and see how the hertz will react on the picoscope. I got my test light, verify that it is indeed working, and I'm going to ground out, and you can see on the graph that it is definitely changing. It's not liking the signal at all. I'm getting 0 volts. If I take it off, the signal returns to what it was before. Put it back on, it goes bad again. What's very interesting is here is we can ground the sensor actually out, and there seems to be no running change on the engine. That could be for a variety of reasons. However, there still may be a code, and we will check that later on. To change the pace up a little bit, we're going to do a little live work, a little misfire diagnosis on this F250 service truck. You can see it has 179,000 miles on it, and when you start it up, the car shakes like a misfire and the check engine light is on. Pulling memory codes, we have OBD system checks incomplete, ignition coil A, primary circuit fault. I'd like to investigate this one to see if it's a current pending code or an actual code that we've had in the past, and just typical other codes that we have. Looking into our actual pending codes of this truck, we do have the P0351, ignition coil A, primary secondary circuit. That could be the possible cause of misfire. What we're going to do is we're going to be further diagnosing, looking at misfire monitors, and seeing if we can individually look at the different cylinders to see what the actual problem is. With this here, you can see our misfire emissions monitor here is indicating yes, as in yes, there is a misfire in the system. In this test, what I'm going to show you is actually the cylinder contribution test, and what this test is measuring is how good the cylinders are actually contributing to the engine. Positive numbers are good, or 0 means that they're not hindering the engine at all, but negative numbers are bad. You can look at cylinder number 1 here. It's sitting at right around 31, negative 31, which is not good. We rev the engine, we can see that the misfire goes away and it goes back to 0. However, when you go back to idle, you can feel the misfire is pretty severe. You can feel it actually in the driver's seat. So taking a look at it, you can see 30, 29, 22, and it'll actually go away if you blip the throttle. Here I am showing the cylinder numbers and the orientation in which they are in the engine. Looking at our diagram here, we have coil number 1 right here, our red power going into our green out to the driver. So we're going to probe the green wire to see what kind of signal we get for the spark on our picoscope. Here you can see that normally if the circuit is functioning correctly, you see a spark between that two tips right there. That'll work to pull the coil out and it's taking the misfire directly where it is not actually firing. You can see that wire, that signal, that voltage actually going through it. You can see the spark coming from the engine on a good known coil.